Good morning, Year 4. Welcome to Tuesday's maths lesson. I would like you to complete the mental arithmetic questions on the board. Please stop the video to give yourself time to do so. Welcome back, Year 4. I'm now going to reveal the answers to the questions and I would like you to mark your answers. Now, if you've been choosing the Sapphire challenge, then hopefully you completed all the questions in green. For everybody else, hopefully you completed the questions in black. Now, if I was looking at 3,478 at 800, remember I'm doing this mentally, I'm doing this in my head, then I will be using my knowledge of 34 at 8 to help me. 3400 at 800 is going to give me 4200, just the same. So I know 34 and 8 is 42. And because I have got nothing in my tens and ones, then my 78 in my tens and ones column from this number will still stay as 78. I hope you had some good success with these calculations today. So we're going to move on to today's lesson. Now, we're going to build on Monday's lesson. We're going to remain looking at equivalent fractions. And I've already told you that we'll be doing fractions for all of this week and we'll be doing it for fractions for next week as well. So building on then our knowledge yesterday of equivalent fractions, today we need to make sure that we can again recognise equivalent fractions. However, you are going to be drawing some bar models to show fractions today. And in order to draw the bar models, you're going to need to consider how long each bar model is going to be. I'm going to come back to that a bit later. To begin with, let's just have a look at something called a fraction wall. Now, we showed you this back in the autumn terms. This isn't brand new to us, but it's a very useful tool for identifying fractions that are the same amount. We can see that this purple bar is our whole bar, and I can see that my two pink halves would be the same amount. My three reddy brown thirds would be the same amount as the whole bar, and so on. Now, if I was looking at fractions that were the same as, say, a quarter, if I do my first cut on this quarter, I just keep extending this down the fraction wall, I can see that, let's just choose a colour that we can colour in with easily. So if I'm showing 1/4, I can see that actually 2/8 is the same amount. I can see that 3/12 is the same amount. But I can also see that 2/7 would be too much because that cut would be here. Or those two amounts would reach here. I can see that 2/9 would be not quite enough because I'm actually going into part of this 3/9. So a fraction wall can help show equivalent fractions. Now today you are going to be, as I said, looking at bar models and some of you drawing your own bar models. So this bar model shows different fractions. It's exactly the same really as the fraction wall you've just looked at, just without so many fractions on it. I wonder if you could stop the video and actually just mentally or just verbally out loud, just point to each block. For example, here's a block and here's a block, and actually just say what the value of them are. Welcome back. I'm going to use a different colour now just to label these up. So this is my whole bar. Starts here, finishes here. I've got no cuts in it. I can see that this bar has been cut in the middle, and for most of us this part is very simple now. I've got one piece out of two, and over here one piece out of two, which we know are called halves. This bar, I can see it's been cut into 4 pieces, therefore my denominator is going to be 4, and each piece is 1 piece out of 4, or 1/4. Sometimes people will call these parts fourths, and that is perfectly acceptable However, we tend to use the term quarter, 1/4, rather than 1/4 more commonly. Hopefully at the bottom you realise there's 8 pieces, so each of these are going to be 1/8. Now, what fractions then, as I label this up, can you see that are equivalent? Hopefully you can spot some pretty quickly because we obviously worked on this skill yesterday. Okay, so I'm not going to label every single equivalent fraction that we can see, but we can see that if I was to colour in this half, that is the same as 1 2/4. It's also the same as 1, 2, 3, 4/8. And just as I did with the fraction wall, if I actually draw my line, I can see, I apologise, that's just, sorry, tricky to use the pen with this sometimes. I can see that they've reached the same distance along the bar. If I was to write them as equivalents, then I would be writing that as 1/2 is equal to 2/4, 1/4, 2/4, and then 4/8. We're pretty good in year 4 at writing fractions, so we can put 4/8, 4/8. I can also see other equivalent fractions in here. For example, if I now change my colour, I can see that 1, 2, 3/4 is the same as 1, 2, 3, 4, 5, 6/8. I apologise if I've done that a little bit quick there. Okay, so 3/4 is the same as 6/8. Now, are there any other fractions that we could show that was equivalent to quarters or eighths or halves? Well, actually, I could very easily show 16ths as one example. I won't label all of these up again, but we know that these were eighths. If I skip back, we can see that. Okay, this same bar here, or this bar model here, is exactly the same as this one, but I've just extended it with another bar at the bottom. And what I've done is I've cut each eighth in half. So half of an eighth is a 16th. Each of these pieces are called 16ths. Now, I won't label this the whole way along, but what you can see is that 2/8 is the same as 4/16, or 1/8 is the same as 2/16. Sometimes we do write fractions with a diagonal line as opposed to actually seeing a horizontal line. So 2/8, this time I use a horizontal line between my numerator and denominator. 2/8 is the same as 4/16. Okay, let's just have a look at a different bar model then for a moment, just that shows different equivalent fractions. Perhaps again you could stop the video now and actually have a look at what this bar model is broken into. Okay, so we can see that this is obviously our whole. I've got 3 pieces, so these are my thirds. Below them I have got my sixths. And then below them, hopefully by now you've counted the amount of pieces and hopefully you've thought to yourself that they are ninths. Now, why just write in ninths? Just have a little think. Why have we not got halves on this bar model? Why have we not got eighths on this bar model. And it's all to do with the fact that certain numbers divide into each other well. On this bar model, 2 pieces divides into 4 well, and 4 divides into 8 well, and 8 divides into 16 well. But 9 doesn't divide into 16 very well, and 6 doesn't divide into 16 well, and so on. So we have certain fractions that work very well together to show equivalence. Okay, some of you might even heard them called fraction families before. So these are fractions that work really well together to show equivalence, and that's just a simple way to think about this. So hopefully looking at this, you can see lots of different fractions that are equivalent. I could, for example, say that 4/6 are the same as 1, 2, 3, 4, 5, 6 ninths. So 4/6 is equivalent to 6 ninths. I'm sure that you can see other equivalent fractions within that model. Now, what about if we looked at this one then? What fractions here work well together to show equivalent fractions? Well, again, we always start with our whole bar. That's consistent, isn't it? Depending on whatever fractions we are showing. We always had a whole bar at the top. That way we know the length of our bar, and the other bars are obviously going to be cut into different pieces. So here I've got one piece out of 5. Looking at the whole of this bar, it's cut into 5 pieces. So I have got my fifths. I could write my number 1 like that if I want to. So I've got 1/5, 1/5, and 1/5. And I'm sure lots of you have figured out that at the bottom we've got tenths. 5 divides into 10 very well. 10 is double 5. Okay, we'll stop there. What we can see again is that 1/5 is the same as 2 tenths. 2/5 is the same as 4 tenths. Okay, so we had 4 tenths, and doesn't matter which way around I necessarily write it, is the same as 2/5. Okay, I'll put my tenths first on this occasion, put my tenths after the equals sign on this equation. Now, this is the part that I know sometimes children find difficult, is drawing the bar models themselves. So if I asked you to draw a bar model that showed a quarter and it showed 2/8, how are you going to draw that successfully? Well, the key bit is you need to look at what's the most amount that you need to cut any bar into. And then you need to make sure that your bar model goes along that amount of squares. So I need to show 2/8, therefore I need to make sure I go along 8 squares so I can show 8ths. Now here is the bar model that I had earlier. It's got 8ths and quarters and halves and a whole. I'm not being asked to show halves this time, so I don't actually have to have a bar that shows a half. But I do need to show 8ths and quarters, and as I said, we always show a whole. So I've gone along 8 squares. I can now happily show that this is 1/8, and this is 1/8, and so on. 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8. So I've definitely got 8 squares there. They're definitely 8ths. Now, in terms of showing quarters, if I make my cut here, I'm going to end up with a huge piece at the end. This is where I can use my knowledge of how many quarters equals an eighth to help me. 2/8 is the same as 1/4, and I can divide this up. Now, really important, fractions involve pieces that are the same size. So I can see with my quarters that the length each time is the same. So if I go back to my question now, I had to show a bar model. Well, I've managed to draw a bar model. I had to show a quarter and I had to show 2/8. This shows a quarter, this shows 2/8. And what I would like to do now is to also colour it to really show it very clearly. Obviously, again, you can actually colour yours so that the whole bar part is actually coloured without any gaps. A bit more tricky for me with these thick highlighters. If you are going to do the sapphire and bronze challenge today, then you might want to start your task now. And I would actually say, don't be put off by the fact that you've maybe always been doing the silver or the gold. I would say that what I'm about to show you for silver and gold is quite tricky. And your understanding of equivalent fractions and being able to draw them would still be very good using sapphire and bronze as your challenge today. So if you want to start the bronze and the sapphire challenge, please start now. So looking at the silver and the gold challenge, you've got to draw a bar model on one of your questions where you've got to show ninths. Now it can be a little bit tricky because numbers don't always divide into 9 particularly well. So my question in red is, will each bar need to be 9 squares long, or would it be better to use 18 squares, and why? Let's have a look. So first of all, if you ignore the 2 bar models that I've drawn, here's one that we looked at earlier, and we know that each of these pieces show ninths, and each of these pieces show sixths, and each of these pieces show thirds. Again, I've got my whole. Now, I need to be showing 6 ninths, 4 sixths, 2 thirds. So I could colour these along, but obviously you've got to draw your bar model today. Let's have a look then. If I'd have gone along 9 squares for my first bar, which is going to be ninths, that works fine. And my bar at the top, always my whole bar, that works fine. Now, if we're going to show thirds, let's do that on the second bar, then thirds, I would need to go here and here. Remember, fractions are always the same size. So I can label those up as a third. I could keep labeling them along, but that will do just for the purpose of the input. Now, sixths is more tricky. Have any of you managed to work out how I would show sixths on this bar? Well, I need to know if I've got 9 squares and I'm going to divide them into 6, what actually is that? Well, it's actually 1.5, or as many of us know, that's 1.5. So what I could do is I could actually make my cut on this bar every 1.5. It's quite tricky. Here's part of the problem. It's quite tricky to get exactly half on the square. So I'm not wholly happy with that. Let's just try just once more. This one, next one's a bit easier because I can go onto the line. So I'm going along 1.5 squares each time. And finally another 1.5 squares. And I have managed to create 6 equal fractions. 1, 2, 3, 4, 5, 6. So I can label this up now as 1/6. Okay. Now, an easier way possibly to do this is actually, rather than draw 9 squares along, to have drawn along 18. Because every second square then would be a 9th. Okay, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces. But I don't have to worry about doing half squares to create my sixths. Each of these is a sixth. The same as each of these is a third. The same as this is my whole. And it's because 6 divides nicely into 18. It's 3. So therefore every 3 squares is a sixth. However, as complicated as that is, I've actually just shown you 2 ways to draw your bar models for this. If you're getting confused, you just need to replay this part of the video, pause this part of the video, and actually copy the bar model down. So today's tasks, hopefully children doing the bronze and sapphire have already started. There's a fraction wall to remind you what to do. There's some squared paper for you to be able to draw your bar models on. Sapphire bronze are colouring and labelling bar models, but then they do have to draw 2 of their own. And there are 3 for you to draw on silver, and then an extra challenge of, can you draw a bar model that shows 12ths, and what other fractions could you show as part of that bar model? So you might be able to show quarters as well, for example. Obviously you would need 3 bars then, 1 to show 12ths, 1 to show quarters, and 1 to show your whole bar. Perhaps some of you could show more fractions than just 12ths, quarters, and a whole. Very similar. Gold challenge has 3 bar models to draw, and then I'd like you to use those to write as many equivalent fractions as you can possibly find. And that's the trick. Can you not just find a few? What's the maximum you can find that are shown on those 3 bar models? So good luck with today's tasks. Don't be put off if you first go wrong drawing a bar model. They can be tricky. Persevere, and I know your teachers are looking forward to seeing your fantastic bar models showing equivalent fractions. Good luck, Year 4.